Hello everyone, welcome you to this new video lecture. Today we will continue on pair of random variables, and the first definition today we will discuss is joint probability mass function. So the basic idea here is the joint probability mass function of discrete random variable x and y is actually written as p with subscript x comma y that represent that you have a two pair of random variables x and y. In bracket you have small xy. Okay, so this means that capital X is related with small x, y is related with small y, is equal to probability when capital X is equal to x comma capital Y is equal to small y. So this is the extension of the discrete PMF to the joint PMF, as we in previous video discussed the joint CDF. So this is for discrete random variables that are in pairs, and it is known as joint PMF. Now let's consider this further in detail. So for this, consider an example here, and it says that you have test two integrated circuits, one after the other. So on each test, the possible outcomes are accept or reject. Assume that all circuits are acceptable with probability 0.9 and that the outcomes of the successive tests are independent. So count the number of acceptable circuits x and count the number of successful tests y before you observe the first reject. If both tests are successful, let y equal to 2. Draw a tree diagram for the experiment, find the joint PMF. So the basic idea here is that we have to test two circuits, and based on that we define two random variables. Now let's here for first one we either have accept or reject. Again we have further, so we just come up with the possibilities of AA, AR, RA, and so based on this we have probabilities. So it is written here that probability of A is 0.1. Now if you remember, we defined x is number of acceptable sets, so in that case here x is 2, here x is 1, here x is 1, here x is 0. Now the second thing is for y. Look here, you have to count the number of tests, so in that case y is 2 here. Similarly y is 1 here because after one successful you have rejection. Here y is 0 because you start with the rejection. Here there is no acceptance, again 0. So that's why we have these values and we just plug in here. So we can represent these outcomes in terms of random variables. Now based on that we can make a table here, and we can say that this is your rows in that represent x, and in columns y is represented. So this is your joint PMF. So for example 0, 0 is 0.01 and so on. So this way we can fill in the table. Now from this table we easily write the PMF, joint PMF. Similarly we can represent this as graphically. Now the theorem that is important, how we calculate the probability. So for example, for discrete random variables, if we have x and y and any set b in the xy plane, the probability of the event that xy belongs to b is calculated. You just have to write all the values that satisfy the b and calculate the probability joint PMF for that, and add up, you get the probability of event B. Now let's look at it further in coming slide. Now to do this, let's consider an example here. So example is the same one that we have. Now here we want to find the probability of B and that X we defined an event B that takes the number of acceptable circuits y equals the number of tests before observing the first failure. Now, mathematically, B is the event when x equal to y. Okay, so event of B with non-zero probabilities are, we just have to pick those ranges where we have this situation that x equal to y. So we have 0, 0, 1, 1 and 2, 2. Now for that case, if we use the theorem and we just plug in the values for 0, 0. After putting the values, we just add the probability, we come up with 0.91. Now, just to understand it further, just look at the graphical representation here. So assume that we have this B event that is represented here in this XY plane. Okay, so this is the B event. So it is not consisting the whole plane here, but a part of it. So when I have to find the probability of this, I have to calculate for all these points and add up. Similarly, this is another point that is marked by a circle. Even can be of anything. Now here it is a circle. Now, to understand this for joint PMF, let's do a quiz quickly. Quiz 1. So this is quiz 2 in your chapter number 4. If you have latest version, then it is chapter number 5. So a quiz says that the joint PMF of two random variables, that is q and g, with small q and g. So this means that we are talking about a pair of random variables, that is q and g, and is given in a table, and table is given, so this represents, rows represents for q and columns represent for g. Now question is calculate the following probability. So first one is probability when q is 0. So for, look here, this is the row where q is 0. For this q is 0, I have to add all the probabilities, okay, in this row. So for this q equal to 0, I have to calculate 0.006 plus 0.18 plus 0.24 plus 0.12. Then I can solve for the first part. Now second is q is equal to g. So for example, q is equal to g means that when q is 0, g is 0. So this is the 1 point I have to pick, plus when q is 1, g is 1. So in that case, so we have to add these two probabilities, we get the answer for second part. Third one, g is greater than 1. Now this is the g and greater than 1, so I have to add all these 4 points where g is greater than 1 for g equal to 2, because there is no restriction on q, so I have to pick 0.24, 0.16, 0.12, 0.01. When I add it, I can solve the third one. Last one is g is greater than q. Now look here, q is 0, g is 0. I don't have to take this, I have to leave this. I have to move further. q is 0, g is 1. So I have to pick this one, 0.018 plus 0.24 plus 0.12. Similarly, for second one, I have to pick 0.16 plus 0.0. When I add it, I easily solve for the last part. Now look at the solution in next slide. So for first one, the probability of q equal to 0, I have to put the values for all events where q is 0 independent of g. So I just say q is 0, g is 0, q is 0, g is 1, q is 0, g is 2, q is, just add all these values, 0.6. Similarly, q equal to g. So in that case, 0, 0, 1, 1. So this is the result. G is greater than 1. So I have to put look for g from 2 to 3 for all q's. So this is the value. Last one is g is greater than q. Again, this for condition where g is greater than. Now the next topic that we have to discuss is known as marginal PMF. So marginal PMF means that if a joint PMF is given to you, how you calculate the individual PMF from joint PMF. So that individual PMF is also known as marginal PMF. So just look at this one. So for discrete case, we have variables x and y, the joint PMF x and y is equal to marginal PMF. If you calculate for x, you have to add up joint PMF with variation for y. So here you can easily calculate the marginal PMF for x. Similarly, marginal PMF for y, you have to uh, plug in the range of x and just add it for that particular one. So to further clarify this concept, let's consider an example. So example is there. So this is the same example. So you have given pxy and x is in rows and y is in columns. So assume that it asks you to calculate the marginal PMF for x and y. So how you do that? For example, for px of 0, you have to add all these values. So px of 0 is equal to 0.01, px of 1 is equal to 0.18, and px of 2 is equal to 0.18. So this is the way you calculate the marginal PMF for x. So for y, you have to do it in columns, just add values in columns. So in that case, py of 0 is 0.2, py of 1 is 0.09, y of 2 is 0.18. So if you look at in columns and add the things, you come up with PMF of y. If you look at in rows, you calculate the marginal PMF of x. Look here, for x I calculate all values for y. So similarly for y I do it. Look here, this is very simple representation. For x, p of x I put here and just add the values in the rows. So when I do that, this row, this column represent the marginal PMF of x. So similarly for y I put here. Look here, the interesting thing is after y you have to put x, after x you have to put y for marginal PMF. So the main idea is when you look at in rows, this gives you marginal PMF of y. In columns, last column gives you marginal PMF of x. So when you add all these values, it comes to be 1. Similarly, when you add up these values, it is also 1. So this here, this corner is also represented by 1. Either you add in columns or in rows. Okay, so this means that you are doing right. Okay, so this is a check where you can look at that the calculation you made is correct or not. Now to understand this, let's do a quiz on marginal PMF. So we have two random variables pair here in terms of h and b. Now we have to find for p of h and p of b. I told you that you have to draw a line underneath this table, horizontal and vertical line. Okay, after we put h, so put p h of capital H of small h. So here you represent the, what you say, marginal PMF of h. So after h you represent marginal PMF of b. So when you add in rows, you just plug in the values here. So it becomes 0.6, 0.2 and 0.2. So this is the values you get. 3 is for marginal PMF of h. Similarly in row, when you add the columns, that is 0.2, 0.5 and 0.3, this gives you the values of marginal PMF of b. So let's see the solution. So look here, this is the solution. Marginal PMF of b is 0.2, marginal PMF of h is 0.6, 0.2. So this is the way you can easily calculate the marginal PMF for h and b. Okay, so I will stop here and we will continue in next video lecture. Thank you.